Hi everyone, today we're going to talk about different types of numbers. The first category of numbers we're going to talk about is rational numbers. A rational number is any number that can be written as a fraction. So some examples of that, like if we talked about the number 2. The number 2 is rational because as a fraction we would write it as 2 over 1. Or another example would be if I gave you the number 2/3. Well, it's already written as a fraction, so that means it's a rational number. Now, negative numbers can also be rational. Like, for example, if we had the number -4, I would say that's rational because I can write it as -4 over 1. Decimals are also rational. Let's say that I had 3.58. So that, as a fraction or a mixed number, would be 3 and 58 hundredths, right? Because the 8 is in the hundredth spot, so that's why we know it's out of 100. So these are some examples of rational numbers. So any decimal that does not go on forever and does not repeat, that's a rational number. 2/3, 2 over 1, so just plain numbers are. So an example of a number that would not be rational would be like pi. Because pi is a decimal that goes on forever, it never repeats, and it never ends, right? It's 3.141592665. Okay, I do have a few more memorized, but we'll just put a ... there. And since you cannot write that as a fraction, that means it's not rational. So this is the one that's not rational. Okay, so now that we know what rational numbers are, rational numbers can then be broken down into other types of numbers. So all of these numbers here, integers, whole numbers, and natural numbers, those are all still rational numbers. They're just finer categories of rational numbers. So an integer, we studied integers at the beginning of the year. Remember, integers are negatives, 0, positives, but we're not looking at fractions and decimals. Whole numbers start with 0 and count upwards. Again, no fractions or decimals. And then natural numbers, think of natural numbers like the numbers you learned when you were really little. So what numbers did you naturally learn when you were little? Well, if you ask a baby, like, how old are you, they're probably going to say 1 and show you, one finger, and then counting upwards. That's how they learn how to count. So the natural numbers start with the number 1 and count upwards. So these are our different categories. So integers, negatives and positives, but no fractions or decimals. Whole numbers start with 0. You can kind of remember that because there's a 0 there and an O in the word whole, so start with 0 and count upwards. And then natural numbers, think of numbers when you were little, what you naturally started learning. So 1, 2, 3, 4. You probably wouldn't ask a baby how old they were and they would respond with, I'm 2/3 years old. Yeah, they don't know fractions yet. So natural numbers start with 1 and go upwards. Okay, so now let's go ahead and practice classifying some of these following numbers. So our options are, we're going to say if it's rational, so let's use an R for rational. And then if it is rational, we want to decide, is it an integer? So let's say I for integer. We also have whole numbers, so let's do W for whole numbers, and then N for natural numbers. If it is none of those, then just write none. Okay, so what I would like you to do is pause the video, take a look at -2.3, that's a decimal, and I want you to just list out, is it rational? Is it an integer? Is it a whole number? Is it a natural number? Or is it none of the following? Then play the video once you have your answer listed in your notebook and see if you were right. Okay, here is your answer. Negative 2.3 is a rational number, but it's nothing else. So remember, a rational number means any number that you can write as a fraction. So negative 2.3 can be written as negative 2 and 3/10. Therefore, it's rational. However, it's not an integer because remember, integers cannot have fractions and decimals. It's not a whole number. Whole numbers are 0, 1, 2, 3, 4, 5. And natural numbers, a little baby is not going to say negative 2 and 3/10. So this is a rational number. Okay, go ahead and pause the video and try the next one. Okay, so pi we had mentioned in the last slide. Remember, pi is none of the following. It's not rational because you cannot write it as a fraction. It is a decimal that goes on forever and never repeats and never ends. Go ahead and try the next one. Okay, here's our answer for negative 5/2. That would be a rational number, but it is not any of the other types of numbers because, again, it is a fraction. Go ahead and try the next one. All right, here we go. The square root of 36 is equal to 6, so that means it is a rational number. It is also an integer, a whole number, and a natural number. Go ahead and try the last one. Okay, the last one is a little bit tricky. We have 6.7 repeating. Repeating decimals can be written as fractions. So 6.7 repeating is 6 7/9, not 7/10. So it is a rational number, but it is not an integer, a whole number, or a natural number. Nice job. Okay, now let's go ahead and move on to the next part of our lesson. The next part is on comparing and ordering rational numbers. So here we have an example where I want you to say if the first decimal is less than, greater than, or equal to the mixed number on the right-hand side. So you are familiar with how to change fractions, decimals, and percents into one another. So what I'd like you to do is change both of these so that they're in the same form, and then go ahead and put an answer in the middle. So for example, 5.7 is a decimal. If we can change 5 3/8 to a decimal, then we would be able to tell which one is larger and which one is smaller. So go ahead and try changing 5 3/8 to a decimal, and then put an answer in your notebook, and then press play to check your answer. Okay, here we go. Here's our answer. So in order to change 5 3/8 to a decimal, I divided 3 by 8, and that gave me 0.375. So if I'm comparing, I have a 5 in the ones place, so that means we need to move on to the next part. We have a 7 and a 3 in the tenths place. 7 is larger, so that means 5 7/10 is greater than 5 3/8. All right, so that was a basic less than, greater than, or equal to problem. Now let's go ahead and give you more rational numbers. And what I'd like you to do is first change all of the rational numbers so that they are in the same format, and then go ahead and list them from least to greatest. Now this first one we're going to do together, so you're still going to write this in your notebook, but let's just make sure that you understand the process okay. So our first rational number is 4.5, so 4.5 as a decimal is 4.5. And then we have the square root of 17, so if I use my calculator to do the square root of 17, I get 4.123. And remember, you want your answer to have a few digits after the decimal point so you can be sure that you know which order they go into. And our next rational number, we have 4.4 repeating, so let's go ahead and list out a few digits of that one. And then the square root of 16 is 4. If you're not quite familiar with square roots, a square root really just means what number times itself gives you 16. So since 4 times itself is equal to 16, that means the square root is 4. All right, so now let's go ahead and list our original rational numbers in order from least to greatest. So taking a look at all of my decimals here, I need to find the ones that is the smallest first. And it looks like the smallest one here to start is going to be the square root of 16, which equaled 4. So let's start by listing the square root of 16. Okay, so that one is done. Now I'm going to check for my next smallest, which looks like it would be the square root of 17. So let's list that one next, followed by 4.4 repeating. Remembering to list our original problem, not the decimal equivalents, and then lastly 4.5. Okay, so now the last part of this is I would like you to take these rational numbers and graph them as points on the following number line. So the square root of 16 was equal to 4, so let's go ahead and put a point here at 4.0. That was the square root of 16. Next, we had the square root of 17, which was 4.123. So if 4.1 is right here, we need to go a little bit farther. And you can just estimate. It doesn't have to be perfect. We know that it's a little bit more than 4.1. Next, we have 4.4 with the repeating bar. So we know it's going to have to be a little bit more than 4.4. So let's go ahead and put that one. And then lastly, we have 4.5. Now, hopefully, if you noticed, when we graphed all of those, we graphed in the direction going from left to right because we were graphing least to greatest, and that's how our number line works. Okay, there you go. So there's an example where we walked through it together. And now it's your turn. So here we go. You're going to pause the video. I want you to go ahead and list all of your rational numbers first in a common form. Probably decimals is what you want to use. Go ahead and list then the rational numbers in order from least to greatest and graph it on the number line. So here's what I'm going to do. I want you to pause the video, go ahead and do the problem, and then I will slowly go through the answers. So that way, if you want to just check your decimals and make sure that those are correct, I'll put that up first before I list out the final answer. So go ahead and pause now. Okay, and here you have your decimal equivalents. So make sure that this is what you had on your paper. And then again, we're going to pause. Go ahead and write your final answer of the rational numbers in order from least to greatest. Okay, here you go. So here's our final answer with our rational numbers listed from least to greatest. Now go ahead and pause the video and put them on your number line. All right, and here's what your number line should look like. Again, when you were graphing them, you should have noticed that they went left to right. Nice job. We're going to do one more example. Okay, here's the last one. Go ahead and write the decimal equivalents, put your final answer, and then graph your answers on a number line. I'm going to go ahead and reveal the answer all at one time, so go ahead and go through all of the steps, and then press play to check your answer. Okay, here we go. Here is the last example. So go ahead and check, see if your decimals were correct, see if you had your final answer in order correctly, and that you put them on your number line. Nice job today.